All right, today we are diving into a biological puzzle that is just fantastic. It all starts with one of the most famous animals on Earth, the elephant. And it ends with a twist so surprising it might just change the way you look at the entire animal kingdom.
So let me ask you right off the bat, when you look at an elephant, what do you think is its closest living cousin on land? Your brain probably jumps to other big, gray, tough-skinned animals, right? Maybe a rhino, a hippo. I mean, it makes total sense.
And look, that's a perfectly logical guess. Elephants and rhinos are both these massive plant eaters. They're part of a group we used to call pachyderms. They really seem like they should be first cousins. But here's the thing about evolution. Looks can be super deceiving. The rhino, the hippo, they're all wrong. The real answer is so much weirder.
The elephant's closest living land relative is actually this.
I know what you're thinking. Is that a giant guinea pig? Maybe a groundhog? Nope. This little guy is the rock Hyrax. It weighs maybe 12 pounds, it's covered in fur, and it scoots around on rocks. And it is, without a doubt, the elephant's closest living cousin. The question is, how is that even possible?
So how on Earth can these two animals be so closely related? Well, to figure that out, we got to jump in a time machine and go way, way back. The common ancestor of both the elephant and the Hyrax lived about 60 million years ago. Now, just think about that for a second. 60 million years is an absolutely immense runway for evolution to work its magic. It's more than enough time for two branches of the same family to go in completely different directions.
But even after all that time, the family resemblance is still there. You just have to know where to look. It's not in the size or the skin, but in the small details. They both have similar teeth and skull structures. And get this, those two big teeth on the Hyrax, they aren't for gnawing like a rodent's. They're actually tiny tusks. And here's a wild fact. Just like elephants, Hyraxes have internal testicles, not an external scrotum.
And this skull just drives the point home perfectly. You can literally see those tusk-like incisors and that unique molar setup. These are the kinds of deep, anatomical clues that don't lie, connecting this tiny creature to the largest land animal on the planet.
But the final, absolute proof comes from their DNA. This phylogenetic tree is basically a family tree for species. And as you can see, right there, the branches for the elephant and the Hyrax split from the same point much more recently than other animals. So this isn't a guess, it's a biological fact written in their genes. But this bizarre family connection is just where the story starts to get even more interesting.
You see, this unique evolutionary path gave the elephant something of a superpower, one that helps solve a huge biological mystery called Peto's paradox.
Okay, so what is Peto's paradox? Here's the deal. Every single time a cell divides, there's a tiny risk of a mutation that could lead to cancer. So logically, an animal with trillions more cells, like an elephant, should be a cancer magnet, right? They should have a much, much higher risk of cancer than humans, but they don't. In fact, elephants have a much lower rate of dying from cancer than we do. For decades, this baffled scientists. So what's the elephant's secret? Well, the answer is in its genetic armor, a unique defense system it evolved to fight cancer. The secret weapon comes down to this one number, 40. That's the number of alleles, or gene copies, elephants have for a super important tumor-suppressing gene called TP53. It's so critical, scientists call it the guardian of the genome. Now, to really put that number in perspective, look at this. We humans, we just have one copy of that gene, which means 2 alleles. Elephants have 20 copies, giving them 40 alleles. That is a massive 20-fold upgrade in their genetic cancer-fighting toolkit. And this has a huge measurable effect. This chart shows the rate of something called apoptosis. That's just a fancy word for when a cell self-destructs after its DNA gets damaged. A human with only one working allele has a very low rate. A healthy human is at about 7%. But look at the elephant. Its cells self-destruct at a rate of nearly 15%. They are literally twice as sensitive as our cells, wiping out potential cancers before they even have a chance to start. Now, it's really easy to look at the elephant's incredible size and its cancer resistance and think of the little Hyrax as just a less evolved, quirky cousin. But that would be a huge mistake. The Hyrax has its own form of hidden genius.
Yeah, it turns out Hyraxes are surprisingly sophisticated communicators. Researchers discovered something amazing about their songs. They don't just sing, they perform. They strategically change their tune based on who is listening.
A Hyrax doesn't just sing randomly.
It makes its song longer and more complex when it knows others are paying attention, like after a fight, when a predator is spotted, or when it's responding to a rival. This shows an advanced cognitive ability to actually figure out the mental state of its audience and then optimize its communication for maximum impact.
So what does all this mean when we put it together? We have two relatives, two wildly different animals who each found a brilliant and unique path to evolutionary success.
This table sums it up perfectly. The elephant went for massive size. The challenge that created was cancer risk, and the solution was evolving that incredible genetic armor. The Hyrax stayed small. Its challenge was predation and complex social dynamics, and its solution was evolving a sophisticated cognitive complexity for communication. It's a beautiful demonstration that, in evolution, there's more than one way to win.
Which leaves us with a final thought. This one, unlikely family reunion, reveals powerful secrets to fighting cancer and hints at the origins of complex language. It makes you wonder, what other profound biological solutions are hiding all around us, just waiting to be discovered, in the animals we think we already know?